Hello guys, welcome back again. Today we are going to look on the DFS, and the DFS actually it's a sorting algorithm that sorts items in a list by looking the depth first for each item. That is meaning you go deeper and deeper and deeper, discover all the vertex, and then traverse back track, and then you start afresh from the vertex of which it has not yet been discovered, and it is in alphabetical order, meaning it is from either if it's digits from 0 to 9 or A to Z in that order. So first we need to code in Python, and in this Python programming we do have two classes for this DFS, I being the author, Prof. Oyondi. In the first step, you're going to have a class of the vertex, which is going to add all the vertex, and then it orders them. Initially, it's them with the color of black, meaning it has not been discovered, and the time, the color, and all those, everything will be zeros. So you can see, you can post a video and just copy this code. It is working very well. Just copy the way it is, and then in the next step we're going to discuss on how we write the code of the graph class. And in this class we do have a tuple of which it is the vertices of that are neighboring to the initial undiscovered vertex, and the time, of course, it is zero, since we are starting right now here to traverse through the graph, and then we get all the vertices. We sort them according to the DFS. Now you can also, as we are going through this video, you just copy, you pause the video, you copy, and then you add the edges, you add the vertex. In this Python programming is that simple. You just copy. The main thing here, it's all about indentation, and in that we do have adding a vertex, adding an edge, and printing a graph. In printing a graph, this is where our main function and our main program now works, because this is where we are sorting all the elements, and this is where they're going to be printed to, of course, to our IDE, that is the interpreter. Down there you can see I have this function of the DFS and the DFS itself, and in this one, first as we printing all the neighborings, you see here I do have first I have the vertex and the neighboring ones, and also I'm printing out the discovery time, and then from there you see it, I'm appending here, I'm appending +1. Since we discover 1, we add a time of 1, and then we continue, we color the discovered one to be red, and then we check here if there is no neighbor that is discovered yet, it is colored black, and then there we traverse back tracking, we go through if we get another vertex that has been discovered, and that is where you can start from discovering other vertices. Then we color it to be blue, and then we increment time with 1. Now we initialize the our functionality of working with the graph. We do have first we print the string length of all the vertices. In this video we have the vertex, we initialize it to the A, and then with A we order all the vertices from A through J, and then here they are, all the edges. Now you can see here A is related with P, A is related with E, A and P with F, C, G, in that order respectively. Now down here it is where you need to check if all the edges are present, and then we print up to 1 in the first step, and then from 1 only one file will alone, and then now here this is our main program that we are calling, and if you run the program here, you can see I'm told to save. I did not save. Don't worry. Now this is our program here. You see it has sorted all the elements here, and it has printed very well, pretty cool, know, anyway, now thank you for watching my videos and download very many of them. I'm coming up with other videos. I like to see you again. Thank you.